Write the number 12,031 in figures. Work out -4, add 6 multiplied by 2. We need to use BIDMAS. Multiplication comes before this add, so it's -4 add 12. -4 add 12. Start at -4, we're moving upwards 12, and therefore we get the answer 8. Oh, this one here, the answer on the sheet, let me just get it right, is B. And this one, the answer is A. Question 3. We're rounding 8.6592 to one significant figure. Let me get my purple pen. One significant figure is this first number. This is your 1. We're drawing a circle around the 8, underlining the 6. The 6 tells us what happens to the 1's digit here. The 8 becomes a 9. It is just 9, and that is answer D. Question 4. What is 45 multiplied by 17? Number of different ways of doing this. I'm going to use the lattice method just here. I'm going to put 45 up here, 17 down here. 5 times 1, 1 times 4, 5 times 7, 7 times 4, 14, 28. And I'm going to add down here, 8 and 8 is 16, carry 1, 6, 7. The answer is 765. If you prefer the column method, you could do it that way. 45, 17, 7 times 5 is 35. 7 times 4 is 28, 29, 30, 31. We need to put a 0. 1 times 5, 1 times 4, and then we add those two together to get 765. Two different ways. Question 5. Oh, 765 is question D. Answer D. Question 5. Work out 0.4913 without a calculator. What we do here, column method is my preferred option, making sure we line up those decimal points. And I like to put a 0 in here. We are adding them together. 9, 7, 1. 1.79 is answer B. Question 6. Work out 3 plus 12 squared. 12 squared is 144. You can calculate that if you need to. Column method, lattice method, or it would be brilliant if you can remember all of your squared numbers. That's what I've got here. 3 add 144 is 147. That's answer A. Question 7. Right, so this is index laws. Do you remember how to do x to the power of 2 multiplied x to the power of 3, for instance? You take your 2, you add your 3, and it becomes x to the power of 5. If you've got x to the power 7 divided by x to the power 4, this is exactly the same as saying x to the power 7 over x to the power 4. This time we take the 7, we subtract the 4, we get 3. So this becomes x to the power of 3. Now we're going to use both of these the multiplication and the division to do this calculation. We take the fact that you've got the same base, whether it's x or whether it's 7. We've got 7. We can use the same rule to use these indices. So we're doing 10 subtract 3 is going to be 7 to the power of 7. We're doing 10 subtract 3 there. All over, just a 7 at the bottom here. Now that 7 is the same as 7 to the power of 1. It is an invisible number. Lots of invisible numbers in maths. 7 subtract 1. 7 subtract 1 is going to give us 6, and that is the answer. We're asked in the question to do it as a single power of 6. The single power of 6 means we have to have something. We have to have 7 as the base with something up here, and that is what we've got. Oh, it says the answer is 7 to the power 12. What did I do wrong? What I did was not add them. I should have added them. Let's go back. Let's go back and change that. Okay, because I saw it wasn't one of the answers on the sheet. I needed to, it meant that I knew to go back. So this should have been 13 here. 13 subtract 1. 13 subtract 1 gave me 12. This is the correct answer. It is answer B. Question 8. Express. Oh, I'm not going to have enough space to do this here, so I'm going to go up. So, question 8. Express 600 as a product. Do you remember what product means? Product means multiply. Product of prime factors. So we're looking at prime numbers here. If you need to, write your prime numbers down at the top. 2, 3, 5, 7, 11, 13, 15, 17, and 19. There are 8 between 1 and 20. We often don't need all of them, but we're going to put them at the top, so I've got that to refer to. $100, 10, and 10. And we've got 2s, 5s, and 2s. We can do it in 2 different ways. We can say 2 times 3 times 2 times 5 times 2 times 5. Count the 2's up. We've got 2 to the power of 3 multiplied by 3 multiplied by, I've got 2 5's, 5 squared. Therefore, this answer is C. Question 9. Work out 4/5 of £60. 4/5 of 60 is exactly the same as saying 4/5 multiplied by 60. And if it helps, put the invisible 1 underneath. We are multiplying the numerators. 6, 12, 24 over the denominators. 5. We then need to simplify that. How many 5s? This is just like a division. So this you could think about as 240 divided by 5, or you could see that there's a factor that can be removed, top and bottom, numerator and denominator. I'm going to use bus stop. Bus stop is absolutely your friend when it comes to non-calculator questions. 5s into 2 don't go. 5s into 20, we're going to carry the 2. 5s into 24, well, we've got 20. 20 is 4 lots of 5, and then we carry the 4. 540 is 48, and therefore the answer is £48, which is answer C. Okay, question 10. Oh, big one, this one. Looks very simple. Right, first thing we need to do, we see mixed numbers. The first thing we have to do is turn those mixed numbers into improper fractions. I'm going to do that over here. 1 and 7/8 is the same as 8 times 1 plus 7, which is 15, yeah, over 8. 3 and 2/5, 5 times 3 is 15, 16, 17 is 17 over 5. So it is multiplication, makes life a little simpler. This is the same as 15 over 8 multiplied by 17 over 5. We multiply the numerators, we multiply the denominators. Now, I look at this and go, well, actually, I can do some simplifying. So I'm going to show you both ways of doing it. I'm going to show you the long way, and then I'm going to show you the shorter way if you can see how to simplify this before you multiply. So if we're doing if we're doing it by multiplying 15 by 17 first, I'm going to use lattice. I like lattice. 15, 17. I've made this really small. 5, 1, 35, 0, 7. I am not sure why I made that so small. At 10, 15, 2, 255. I believe that's right. We'll see in a minute. 15 times 17 is 255. And then we've got 8 times 5, which is 40. Now we can either do 255 divided by 40 at this stage, or what I'm going to do is actually simplify here. And this, again, it's a big number. I know that I know these, 5 is a factor. Both of these numbers are in the 5 times table because the 5 and the 0. So now I'm going to use my friend bus stop to find out how many 5s go into 255. I don't know about the 4s, I don't know about 8s, so I'm just going to do this right now. 5s into 2, carry the 2, 5s into 25. This is 51, so this is now 51. 4 divided by 5 is 8. And therefore what I now need to do is how many 8s go into 51. I could write my 8 times table down the side of the page. 8, 16, 24, 32, 40. I'm still not up to 51. 48 and 56. Okay. 1, 2, 3, 4, 5, 6, 7. 51 is 48, and therefore there are 6. Therefore, we have 6 whole numbers, 6 wholes, and left over after we've got 48, we have 3 8s. Okay, I said I would show you the simpler method. So we're going to take this 15 over 8. We're going to multiply by 17 over 5. But this time, what we're going to do, we're going to simplify here. We can take the fact that there is a factor of 5 here and here. We're going to divide the numerator and the denominator by 5. This divided by 5, this divided by 5. And then what I'm doing is I'm taking 3 multiplied by 17 and 8 multiplied by 1. This is far friendlier than having to multiply 15 by 17. This gives me my 51 over 8 straight away. So I didn't need to multiply 15 by 17 and then simplify it. I went straight to this simplified version. I can then use from 51 divided by 8, I can then take that straight to 6 and 3/8. Now this is where I hold my breath and just make sure that's the right answer. Luckily, it is. The last one here, just squeeze it in here. We need to write 736,000 in standard form. Some people move the decimal point. I like to move the 7. So if this isn't your method, then you might want to just check your method for being able to get the same answer as I do. This is 7. It jumps what? Well, I'm going to start by doing 7.36 multiplied by 10 to the something. 1, 2, 3, 4, 5. It moves 5 spaces. If you're moving the decimal point 736,000, you're moving it to get to here. So again, you're moving it the other way, but you're moving it 1, 2, 3, 4, 5 steps. So same steps, but the decimal point technically never moves, but teachers teach it in 2 different ways. This is the same answer regardless, and this is answer C. Moving on to algebra, we're looking at simplifying. Oh, there's an X. We're collecting like terms, the 3x and the 5x. Positive 5x gives us 8x. Now we have to be really careful. We have to keep the negative symbols with these terms here. And what we're doing is we are looking at negative 2 subtract 1. Negative 2y subtract 1y gives us negative 3. Oh, y. And therefore the answer is A. Simplify. 3n multiplied by 2n multiplied by z. This is the same as writing 3 multiplied by n, multiplied by 2 multiplied by n, add z. There's an invisible multiplication symbol between the 3 and the n, so I've just written it out like this. Now, we can rearrange this. If we had 2 multiplied by 5 multiplied by 3, for instance, the answer is going to be 10, 3, 30. If we rearrange this, 3 multiplied by 2 multiplied by 5, 6 times 5 is still 30. Commutativity says that we can move the numbers round and it doesn't make a difference to the actual answer, and that is what I'm going to use here. I'm going to say, well, actually, I like my 3 multiplied by 2 because I know what to do with those. Then I'm going to multiply my n and my n, and then I've got my z left over at the end. 3 times 2 is 6. N multiplied by n squared, and then we've just got the z afterwards. Now, if you thought it was 2n, n add n is 2n, but n multiplied by n is n squared. You need to learn this if you haven't learnt it already. Really important, that. 14, we are simplifying again. Now, we have to pay attention to that invisible 1 again. It doesn't have a number above it. It is a 1. We're looking at the rule x to the power 4 all to the power of 5. Well, this time we're taking 4 and we're multiplying by 5, which gives us x to the 20. When we come to look at this, we have to do it with, let me just write it out in full. You wouldn't really write this out like this. X to the 2 multiplied by 3. And then we take that 1 and we multiply it by 3. And we don't need that multiplication symbol. Oh, I forgot to put the answer here. 13 is D. Here we're looking at D again. Okay, question 15. P equals 5Q squared 2 QR. Now we need to find the value of B when Q equals 4 and R equals -3. So we are substituting. Everywhere we see a Q, we're going to put a 4. Everywhere there's Q here as well. Everywhere we see an R, we're going to put a -3. We've got to be really careful with this negative. So when I use it, I'm actually going to put it in brackets. P equals 5 multiplied by Q squared 4 squared. Subtract 2 multiplied by 4 multiplied by -3. 5 multiplied by 16. Do that in whatever way you need to. It is 80. Pretty sure it's 80. 2 multiplied by 4, 8. Multiplied by 3 is 24. Gosh, where did my head go just then? However, it is -24. So what we're doing here is we are adding 24. Subtracting a negative number means that we are adding 24. 80 plus 24 is 104. And this answer is B. I was beginning to doubt myself there. I'm trying to do 8 times 3 fast in my head. There are some times tables that I just don't like. We're going to expand and simplify. This negative is going to cause us a big problem. So I'm going to do these two separately. I'm going to do 3, 4a plus b. So I'm going to expand this, which will give me 12a plus 3b. Use a grid if you need to. 3 times 4a is 12a. 3 times b is 3b. So this is the first one. Here, -2, a subtract 2b. I'm actually going to use the grid for this because actually it helps me not to make a mistake. A subtract 2b, and then we're multiplying by -2. Got to be really careful here. Yes, it says subtract 2, but it's like adding a negative. We need to use negative here. -2 multiplied by a is -2a. And this is the tricky bit. -2 multiplied by -2b is actually positive. 2 times 2 is 4b. So this is -2a add 4b. We're going to put these together. 3 brackets 4a plus b becomes 12a plus 3b. And then this here is, remember we've dealt with this, so we use whatever is in here. 2a plus 4b. And then we're going to simplify it. So again, we are looking carefully at our terms, still with the signs in front of them. 12a subtract 2a is 10a. 3b plus 4b is 7b. So the answer here is B. We're going to factorize this time. We're going to factorize fully. Eight x squared. Now, factorize means put into brackets. Now, although this has got an x squared term, we are only putting this into a single bracket because there is a like term here and here. In fact, there's a like term in the 8 and the 2, and there's a like term in the x's. So what we do, we've got a factor of 2. We're actually going to put this only in a single bracket. If it works in a single bracket, brilliant. If it's got another term here and you can't take a common factor out, then what we're looking at is a double brackets. Okay, so I'm going to take the term 2 out of here. 2 multiplied by 4 becomes 8, and this is just going to be a 1 here. I know it's going to be subtract, so it'll be subtract 1, maybe something after it. I've got x squared here. X squared is made up of x multiplied by x. We've got an x here as well, so I can take x as a factor at the front. 2x multiplied by 4 doesn't quite make 8x squared, so we've got 8, but we have to put another x here. 2x multiplied by negative 1 gets us to that negative 2x. This is B. Okay, Trixie, this is solve. 6x plus 2 equals 8x, subtract 1. Okay, we have to make sure all the x's are on one side. We choose the smallest number of x's, and we're going to subtract it from both sides. 8x subtract 6x. Then we're going to add the 1 to both sides. And then we're going to divide by 2. And this is the same as 1.5. This 3 over 2 is the same as 3 divided by 2, which is 1.5, which is the answer D. So we're going to solve the inequality. That would be better if you could see it. Solve 3x plus 1 is less than 8 subtract 5. We've got to get all the x's on the same side, just like we did above. So we're going to subtract x from both sides. This makes it 2x plus 1 is less than 5x. Sorry, negative 5. We haven't done anything different than we did up here. We've moved all the x's. The fact that the equal sign is here and there is a inequality here, we didn't do anything different. Here, we want to end up with just x on this side of the inequality. So what we're going to do, we're going to move the 1, we subtract it from both sides, which gets us to negative 6. And then we're going to divide both sides by 2 to give us negative 6. Divided by 2 gives us negative 3. This is answer D. Question 20. Nth term. So we're trying to find the nth term for the sequence 8, 11, 14, 17, and 20. The jump here, 8 to 11, is 3. We're adding 3. 3 is the number, and it's a good idea to check it because it might not be a standard nth term sequence. What we do is we say 3n. This is going up in our 3 times table. Yes, it doesn't look like our 3 times table. So what we do is think about our 3 times table and we go, what do we do to get from our 3 times table to this number here? We're going to take 3, we're going to subtract 5. This is the number that this is the nth term, this is our answer. This is answer A. You can think about it as what is the term 0? Technically, there is no term 0, but if we were going this way, we would be subtracting 3, and that becomes a 5 here. Different ways of thinking about it. Now, question 21. What we've got is, we've got a coordinate grid. We've got a square. This is our y, this is our x, this is 0. We've got S and R, P, 4, 1, and Q, 7, 1. Okay. We need to find the coordinates of R. So we need to find those coordinates up there. This, if we were to trace this down, this is going to, the x coordinate, the x ordinate is 4. Here, the x ordinate is 7. Now, R will have the same x ordinate. So R will have the ordinate 7. And then if we think about it going this way, we need to find where it crosses the y. We have to think about this a bit more. We've got to think about all of it. We're going from 4 to 7. The distance between 4 to 7 is 3. Every dimension, because this is a square, is 3. So we're taking this, the y ordinate for both of these is 1, and we have to add 3 to get us to 4. So this will be the answer, which is answer D. And finding the equation of this straight line, we know it is crossing the y-axis at -1. Let me just put this in here. The equation of a straight line is y equals mx plus c. So I know that c must be -1. C is where it crosses the y-axis. To find my m, we use the formula y equals change in y over change in x. So I'm looking at here. If I draw a triangle, let's draw this all the way to there. Let's draw this triangle in here. Changes y is going from 0 to 2. Change in x is going from 2, 3, 4, 5. Actually, it goes all the way up to 6. So it's 1, 2, 3, 4. Change in y is 2. Change in x is 4. Therefore, it's not y here, it's m. This is the gradient. The gradient equals 2 over 4, which is the same as a half. So if we look at the options here, we've got -1 and -1. So it could be one of these. It can't be either of these because they don't have negatives. And then the gradient is a half here. So this is the right answer. Question 23. Distance time graph shows a hike. This is the distance from home. This is the time. During which section was the hiker stationary? They're stationary when they do not move any further or any nearer from home. So this is the bit that they are stationary. It is B. So we're looking at the velocity time graph here. This time it's not distance, it is velocity. Velocity means speed. It's in meters per second, if that gives you a hint as to what's actually happening here. The time is across here in seconds. We've got some statements here. Let me describe what's happening here first. So just like a normal runner, if they start having no speed at all, over the first second, the speed increases. So they got getting faster. It's actually, the person is actually accelerating here, is going faster and faster. At 1 second, between 1 second and 4 seconds, they're still speeding up. They're still going faster and faster because the speed is going up, but it's not as fast. It's not going up as quickly as it was before. So this is a bit like a sprint, and this is still getting faster, but not getting faster as fast. Then what's happening here? Well, it's not that they're stationary, it's not that they've stopped. They've been getting faster and faster and faster, and now they're running at a constant speed. This is our constant speed. So you can look down these and eliminate them. The runner was moving fastest for the first second of the race is the correct answer in this case. This is the fastest. You can have a look at over the others as I've explained what's happening in the different sections. Okay, question 25. I'll put this here. We need to expand and simplify. Two x plus 3 squared. Now, the most common thing to do at this point is to square this and then to square this term. No. Squared, if we thought about 5 squared, for instance, it is the same as taking that 5 and multiplying it by another 5. The squared means that whatever is here, whether it's 5 or an x, for instance, maybe a y squared equals y times y, whatever is here, we have to multiply that whole thing by itself. So we're taking this bracket and multiplying it by this bracket. I'm going to draw a grid. Two x multiplied by 2x, 3 multiplied by 2x, 3 multiplied by 2x again, 3 multiplied by 3 is 9. I'm going to write them out and simplify them as I do it. This is going to equal 4x squared. 6x plus 6x is 12x, and then I've got 9 here. Question 26. All right, this graph here, I will tell you that this is a graph of y equals x squared. This is a graph of y equals negative x squared. Now, they're not exact, they're not quite on the line, so there are some numbers that go over it, but this is the sort of curve you are expecting. The number away from the x is where it crosses the y-axis. So here, it's crossing at -3, for example. Here, it's crossing at +3. So therefore, this actually becomes x squared subtract 3. And this becomes -x squared because it's over the other way, add 3. And that is actually what we're looking at, y equals -x plus 3. It's not actually written that way in the answer. It's written y equals commutativity. We can swap these two over as long as we keep the x squared with that negative symbol. So 3, we're bringing all that over here, -x squared. And I am hoping that that is, yeah, indeed the right answer here. Sometimes I hold my breath to make sure I've done it right. Okay, question 27. We're going to factorise x squared, subtract 4x, subtract 12. When we factorise, what we are doing is we are putting it into double brackets. We're going to want double brackets here. I'm going to take that 12 and I'm going to put it into factor pairs. Then I'm going to choose two numbers, one factor pair that's going to make me -4. Now, it's -12, so what I need to do is to have one of these two numbers one of these factor pairs to be negative. The two that I actually need in this case are 2 and 6 because if one is negative, I'm subtracting one from the other. This is -4. So what I'm looking at is I've got my 6, I've got my 2, and if I take my 2 and I subtract my 6, I get to -4. So this becomes +2, and this one here becomes -6. Which is answer C. So we're going to solve the equation. Here, we're going to factorize it in the same way. Difference is that we've got an equal 0, so we need to take account of that. What we're going to create is 2 brackets equals 0. Just as we did before, I'm going to find all the factors, 8, 4, and 4. So we could be using 4, and we don't usually write it, but there's another 4 there for our factor pair. Add 16 means they're either going to, the factors here, I'm going to put my x's in, are either going to be both positive or they're going to be both negative. And to make that negative number, I need to take -2 and -8 because -2 subtract 8, -2 subtract 8 is going to give us, negative -10. That's not really what, let's do that again. This is factorized. This is halfway through the question. And what we now need to do, we need to find the solution. We need to say, well, if there are different ways to do it, I'm just going to put the answer down. If it's -2, it'll be x equals +2. And if it's negative again, it'll be x equals 8. And therefore the answer is C. Okay. Put this off the top of the page. Question 29. All right, simultaneous equations. Now, this is the first time that I've actually done this question, so bear with me if I get it wrong. Right, 6y, 2y, I need them to be both the same. I can leave this alone, and I can multiply this by 3. So if I multiply all of that by 3, let me put that in a circle. X multiplied by 3 is 3x. -2y multiplied by 3. And I still need to multiply this 9 by 3 as well. I'm going to write everything there just above it. I didn't need to change it. Now, the signs are not the same. If the signs are the same, then we subtract them. In this case, we're going to have to add. We add these terms here. 5x plus 3x gives us 8x. Positive 6y, we subtract the 6y, it just gives us 0. We're adding 5 and 27, which gives us 32, which is good because 32 is a multiple of 8. I'm going to divide both sides by 8, which gives me 3. Is that one of the answers? Looking down, simultaneous equations. No, it's not one of the answers. Right, what have I done wrong? 5, 6y. I've multiplied everything by 3. I added them. Divide by 8. Okay, I'm confused. I'm going to pause and work it out. Now, you probably spotted it before I did. 32 divided by 8 is not 4. Sorry, it's not 3. It is 4. There's my 8 times table. I should have halved it and halved it and halved it again. I didn't. X is 4. I'm happier now. I have the answer here. It is a multiple choice question, and therefore I know the answer is going to be B here. However, in an actual exam, getting to X is not going to help us. Well, it's going to give us part of the mark, but it's not going to give us the whole mark. So let's put this x back into this equation. Let's write this equation back again. And let's just prove we've chosen the right answer. X is now 4. 4 subtract 2y equals 9. We subtract 4 from both sides, which gives us negative 2y equals, but what are we doing? 4, 5. My head wasn't working there. And then it's actually negative 5. No, it's not. It's positive 5. 9 subtract 4 is 5. Then we are dividing by negative 2. We need a y here, not a negative y. So we are dividing both sides by negative 2. 5 divided by negative 2 is negative 5 over 2, which is the same as negative 2.5. There we go. That's what we needed with those two answers for B. Okay, question 30. M equals 6. R subtract 20. I'm going to do this in two ways. I'm going to do it with boxes to start with because I really like the box method for rearranging formula. We've got to make R the subject, by the way, which means we've got to have R equals something. You start with an M. No, we're going to start with the R. With the R, what's happening? We are, first of all, multiplying it by 6. Then what's happening is we are subtracting 20 from it. That is giving us the M. When we go backwards, we are doing the inverse. We have to do the inverse of subtracting 20 gives us adding 20. We're doing the inverse of multiplying by 6. We are dividing by 6. And therefore we can write R equals M, add 20, all divided by 6. Now, if you've never used that method before, what you're probably used to doing is doing it as a column. So that's what we're going to do now. That's an R there. So this method, and there are more than just two methods, but this is the one that you might be more familiar with. As I say, I'm a real fan of the boxes. We are looking at M equals 6, R subtract 20. We are going to add 20 to both sides. This makes it M add 20 equals 6R. And then we have to divide everything by 6, which gives us M plus 20 all over 6 equals R. Same answer, different method of getting there. Lots of people want to divide by 6 at this point, and therefore this method actually gets us in the habit of adding the 20 first. So if you were thinking that you had to add the 20, consider using this, writing down what's actually happening to R, and then going backwards and doing the inverse of each of those steps. What are we doing? We are doing answer A. Yep, double checking.